Hi everyone, welcome back to my channel again. Today I'm going to talk about the reductive amination. Especially this is also called reductive alkylation. So if you have the primary amine or secondary amine or tertiary amine, especially primary secondary amine, and you want to put an alkyl group, then how you are going to do? Normally, if you have primary amine, and if you want to do methylation by using methyl iodide, so you cannot, like, if you want to put only one methyl group, so it is very difficult to control to make monomethylation, especially in this amine, because you can come up with monomethyl dimethyl trimethyl, like ammonium ion. So it may be tough to control those things, and it also can be difficult to purify from the reaction mixture if you need only one methyl. Not only the methyl, like any other alkyl group, suppose you are trying to add long chain alkyl group like with iodo or bromo with the amine, so it can be also giving this kind of mixture. But what if you want to make only one alkyl group attached in this primary amine? So there is a way to do that, that is called reductive amination or reductive alkylation. So let's see how it works. So for the reductive alkylation or amination, you need to have an aldehyde to react with this amine, and this amine and aldehyde, and also you can use a ketone. So in case of ketone, so definitely you will have two carbon separately, like if you add like these two alkyl, so whatever, so it will form, these two will be gone, it will form a imine. So how does it looks like? This is looks like this is imine, and that imine can be reduced to carbon nitrogen single bond. So by reduction process you can make NHCH. So ultimately in the amine you just attached one alkyl group, so that is called reductive amination or reductive alkylation. Let's see how does it work and what are the reducing agent used for this purpose, and what is the mechanism. So basically in primary amine you can use aldehyde alkyl chain to do the monoalkylation. So in that case, as a reducing agent, the common reducing agent can be used sodium BH3 cyanide, like sodium cyanoborane. But there is a problem with this reducing agent, because after the reaction as a side product, this can give you hydrogen cyanide and sodium cyanide. And you know, all of you know, like hydrogen cyanide and sodium cyanide are so toxic, like very toxic. So as a side product they are giving those, this reducing agent can give those, and that's why people try to take different reducing agent. But in many cases still people use this, because in some cases it works better than the other one. The other one is called triacetoxy sodium borane. So like borane. This is the reducing agent. sodium triacetoxy borane. Oh, there should be one hydrogen here. So let's see the mechanism of the reductive alkylation or reductive amination. So first take an example. This will be your aldehyde, and so it will go to the nucleophilic attack and it will form and since nitrogen giving electron, so it become positive charge. Now after that, these negative oxygen will take one of the proton from here. It is in absence of acid, because in some cases if you add little bit acetic acid, one equivalent acetic acid, in that case this carbonyl carbon get protonated first, then that reaction mechanism is different. But if you don't need to use the acetic acid directly, like use the aldehyde and the primary amine and then the reducing agent, then the reaction mechanism should go this way. And then you can draw R1C. We can put the hydrogen here and OH here, and since this hydrogen is gone, so this nitrogen become neutral here, and R2. And after that it will reduce a molecule of water like these and these, and ultimately this carbon nitrogen will form a double bond that is called imine bond. So we can see this imine bond. Now this imine bond will be reduced with the reducing agent. In that case, this carbon will get one hydrogen and this nitrogen will get one hydrogen, and ultimately the single bond will be formed, and whatever the length of this alkyl group will get monoalkylation. So this is how this reaction occurs. So now how this imine get the reduction. So definitely you are using borane, sodium borane, like so ultimately this is the source of hydrogen, so it will reduce this imine bond and it will form this so ultimately you can show RT, R2, MH bond CH2R. So in the nitrogen you're doing monoalkylation. So this is the mechanism of formation of like monoalkylation in the primary amine. Now I'm gonna show how to set up that reaction and how to get your product. That is very simple. Just you will mix this together in 0 degrees Celsius. Even sometimes those reactions work in room temperature. So I'm going to mix these two in a vial at 0 degrees Celsius. Then like with the THF, like I will dissolve this THF and maybe stir 1 or 2, 3 minutes, and after that I will add this triacetoxy sodium borane as a reducing agent, and then I will start the reaction at room temperature for 2 hours. Here I have prepared an ice bath for the reaction setup. So I will put my reaction vials there. Here one vial containing amine and another vial contain aldehyde. So my aldehyde is liquid. So I'm going to add the THF in my aldehyde solution while my amine with the stirring bar is cooling down in the ice bath. So here I'm adding THF like tetrahydrofuran anhydrous tetrahydrofuran solvent. I'm gonna take 1 milliliter of the solvent first, and then I will add in the aldehyde containing vial. Then I'll try to dissolve all of it with this solvent. Once it dissolved, then I'll take the solution of aldehyde in THF and I'm going to add that solution in my original amine containing vial at 0 degrees Celsius. Here I'm taking the solution of aldehyde in THF from the vial, and I'm adding my aldehyde solution in THF in the amine containing vial at 0 degrees Celsius. Once it is added, then I'll use another syringe to take a little bit more solvent, THF, and I will rinse out my aldehyde containing vial. Then I'm gonna use the same solution again in the same amine containing vial. So here I'm adding the THF. I'm trying to rinse out the vial. And I'm gonna use the previous syringe because it might have some compound also. So I'm taking out that solution, and now I'm gonna use it in the same amine containing vial at 0 degrees Celsius. Once this is done, then I will put in the ice. So ice, and make sure it is tightened nicely, and then I will stir the reaction mixture. So here the reaction is stirring. While I'm stirring at 0 degrees Celsius, in between this time I'm going to measure the sodium triacetoxy borane reagent as a reducing agent. It is from Sigma Aldrich. Here I'm measuring the required amount I need for this reaction. This is a small scale reaction. The amine was like 120 milligram around. So my measurement is done. Now I'm going to take out quickly because it is already cooled to 0 degrees Celsius. So if you take this out for a moment, it is okay. But remember, for a large scale reaction, don't take it out. Set up the reaction in a round bottom flask and keep the round bottom flask at 0 degrees Celsius and open it and quickly add it. But since it is a small scale reaction, that's why I am taking out the vial quickly, and I have added the reducing agent triacetoxy sodium borane. Now once it is added, then I will keep it for 10 minutes here for stirring at 0 degrees Celsius, and after that I will remove the cooling bath, ice cooling bath, and then I will start this reaction for 2 hours. So this is after 10 minutes. I removed the ice cooling bath, and I'm gonna running this reaction to stir for 2 hours at room temperature. And once it is done, then I'm going to work up this reaction. Workup is very simple. Just remove this THF with the rotovap and then add a little bit water. So I'm making vigorous stirring here. After 2 hours, my workup will be just here. I'm saying how to do the workup. Then I'll remove the THF solvent by rotary evaporator, and after that, the remaining part I will add little bit water in it, and then I will add 1 molar sodium hydroxide to make pH around 7, and after that I'll do the extraction in the chloroform, and my product will be in my hand. Very simple. So if you have any questions, you can ask me in the comment section. And thank you for watching my video, and thank you for your support who already subscribed my channel, and who didn't subscribe my channel yet, please subscribe my channel and click the bell button to get the update for the new videos. Till then, stay safe and goodbye now. Bye.